You are welcome to today's class, and today we are talking about the current division rule. The main question is, how does current divide within the circuit? Let's say, for instance, you have a simple circuit like this, and one thing about this section is that you need to watch the video on things in series and things in parallel so you can follow this section very well. Part 1 to part 3, things in series and parallel, because we are going to use it so well here. Let's say, for instance, here is 3, here is 6, here is 2, and then let's say here is 16 volts. The main thing is that we've learned things in series and parallel, and we can easily get to know the total current that is flowing within the circuit. And how do we know the total current? The total current will definitely be the voltage over the total resistance. And we have learned how to find total resistance. So in this circuit, we can all see that 3 and 6 is in parallel. I'm sure you went round. If you have watched the video, you realize that you have to go around to know 3 and 6 are in parallel. So you have 3 times 6 over 3 plus 6. This gives me 2 ohm. Now after, I think in that class, we learned how to use your eye so that you know be redrawing with time. So this 2 ohm, after we know it is going to be in series with this. If you watch that video, you'll be able to understand that it's going to be in series with this. So realize that the total resistance is 4 ohm. It's going to be 2 ohm plus 2 ohm, which is 4 ohm. Realize that the total current flowing is 16 volts divided by the 4 ohm, and that is going to give us 4 amps. So easily we get to know the total current is 4 amps. But the main issue we have here is when this 4 amp gets to this junction, how do we know how much will come here and how much will come here? Somebody say 3 amp will come here and 1 amp will come here, right? Somebody say 2 amp will be here and 2 amp will be here. Somebody says 3 amp rather will be here, 1 amp will be here. So realize that we don't really know how current divides among resistors, right? And we are going to use the concept of the current division rule to see how current actually divide between two resistors. Let's start this with a simple proof, and don't worry much about the proof I'm about to do. I'm trying to look at, let's say for a simple circuit like this, let's say this is the total voltage and the total current here, right? And I want to know if this total current gets to this junction, how much will come to this resistor R1. Let's say, let me call it I1. Now from this circuit, we easily know that I1, this voltage is actually the same voltage across R1, the same voltage across R2. So actually the voltage across this R1 is V, right? So the current in R1 is basically V over R1, right? So this is the current that will actually come to this resistor. But the main thing we want to know is this total current, how did it divide? How much came here and how much will go here? First, let's look at I1. We have seen that I1 is V over R1. Now this V, in terms of the total current, how do we know this total current? This V is equal to, realize that R1 and R2 are in parallel, times this total current is what is going to give us this V. So V is actually equal to IT, that's the total current, times R1 and R2 in parallel, right? Realize that when things are in parallel, this is what we do. Go and watch that video. Now, realize that the total voltage is IT times the total resistance, which is here. So it means that I1 actually is the total voltage, which is R1, R2 over R1 plus R2 IT, that's this, over all this over R1. So realize that R1 cancels one of the R1. We are going to get I1 to be equal to R2 over R1 plus R2 times IT. So this tells us that if the total current gets to this junction, how we get to know how much will come here is that we have to do the other resistor. Realize that we got R2 over R1 plus R2 times the total current. So if I have two resistors like this is R1, another here to be R2, and I have the total current. and I want to know how much will come here, I just have to do R2, this the other resistor, over the two sum times that total current. Now you can go through this proof and realize that the current, let's see, current that will come here, I2 happens to also be R1 over R1 plus R2 times the total current. So it means that if I have the total current and I want to know how much, how it will divide among two resistors, I will say that the other resistor over their sum times the total current. So I want to know I1. So I'll say R2 over the sum of R1 and R2 times the total current. A simple example will explain this so easily for us. Now let's see something. Let's say I have this. Now, let's say I have a simple circuit like this, where a resistor here is 2 ohm, a resistor here is 3 ohm, and I have current of 10 amp coming to them. And I want to know how much will come to this 2 ohm. Visually, you'll not be able to tell, but a simple proof we did shows that if I want to know the, let me call that I1. If I want to know the current passing through the 2, which is I1, I have to use the other resistor, which is 3, over the sum of the two resistors, 2 and 3, times the total current. So realize that I1 is going to be, this will give me 5, so we'll go here 2, so it's going to be 6 amps. So what it means that when this 10 amp comes here, we have just gotten to know that the current that will come here is 10 amp. And we got to know this using something we call the current division rule. So this thing that we just did is what is called the CDR, current division rule, right? So it's by this rule that we get to know how much. So if I want to know how much will come to this 3 ohm, this 3 ohm resistor is going to be 2, the other resistor, over their sum times the total current. Realize that you're going to get 4 amps. So what that this 10 amp, when it gets here, 6 amps comes here, and then the rest of the 4 amp comes here. So this is basically the current division rule. If you have two resistors and you know the total current, the current in one is the other resistor over their sum times the total current. Let's see another example. If I have here to be say 11 amps and I have a resistor here, this is 4, this is 7, then I want to know how much of the current will come here, how much of the current will come here. Let me make this 8, right? I want to know how much of the 11 amp will come to the 4. The basic current division rules is use the other resistor, because we want to know the one in the 4. So use the other resistor, which is the 8, over the sum of 4 and the 8 times the total current. You are going to get 88 on 12, right? Which is actually going to be 44. I can say 4 will go here, so I can use 22 on 3, right? So the 11 and 22 on 3 will come here. How do I know how much will come to the 8? It's going to be the other resistor, 4 over 4 plus 8 times the 11. Then I'll get 44 on 12, which is also 11 on 3. So basically, you realize that if total current is coming, it shares among two resistors using the current division rule. Now realize that all the ones we have done, the two resistors have to be in parallel. The two resistors have to be in parallel before we are able to apply the current division rule. Because if they were in series, let's say this 4 and this 8 were in series, then if 11 arm is coming, the same 11 arm will pass through all of them. So realize that the current division rule is used only when I have two things in parallel and I know the total current coming to them. Now let's use the concept of the current division rule to solve a simple question. Let's say, for instance, I want to know the current in this 4 ohm resistor IA. Now, most of the time in this simple circuit, you can decide to apply the Kirchhoff's laws we have learned to actually find the current IE. But sometimes Kirchhoff will lead you to a lot of simultaneous, like this question, it will lead you to about 2 simultaneous equations you have to solve before you be able to get to know IE. But one thing is that as soon as you start seeing some things in series and some things in parallel, you can easily start applying the current division rule, because the current division rule is applied to two things in parallel. That's two things in parallel that we are aware of the total current coming to them. So let's see how we can use that concept to solve this simple question. So now, if I we can all see that this 4 and this 6 are in parallel, right? If you go around, you realize 4 and 6 are in parallel. So if they are in parallel, if I can know the total current coming to them, I can easily know how much of the current will come to the 4. So how do I find the total current? We all know I have to find the total resistance, and then I will do the voltage divided by the total resistance, and I get the total current. So how do I find the total resistance? Realize 4 and 6 are in parallel, so 4 times 6 over 4 plus 6, and this is 24 on 10, and that's 12 on 5, right? Now this 12 on 5, this and this in parallel, realize to be in series with this, so 12 on 5 be in series with 3, and I'm going to get 27 on 5. So the total resistance is 27 on 5. So how do I get to know the total current? It's going to be the voltage 54 divided by total resistance, which is 27 on 5. And this is going to give me the total current as 10 amps. So now I know this current as 10 amps. So how do I know how much will come to the 4? From here, I'm going to apply the current division rule. Why? The criteria has been met. I know the total current and I have two things in parallel, so I can apply the current division rule. So how do I know IE? IE is the current in the 4. So if I want to know IE, according to the current division rule, I have to use the other resistor, which is the 6, over the sum of 6 and 4, 6 plus 4, times the total current is 10 amps, and this will give me 6 amps. So it means that the current IE is 6 amps. Simple, right? So we just use some simple step. That's the current division rule, and with some few steps, you are able to get to know the current here without solving simultaneous equation. So this is the basic understanding of the current division rule. This is the part 1 of this video. In part 2, we'll solve more examples of how we can use the current division rule. Thank you very much.